Today, our session topic was how to understand and leverage statistics in supply chain planning. So basically why and how businesses are utilizing stats and stat models when planning for demand and running their supply chains. So to start it off, the basis for using statistics in supply chain planning comes from Thomas Bayes, who lived during the early 18th century. He's a famous mathematician, and there's an entire branch of mathematics based on Bayes' theorem known as Bayesian statistics. In a nutshell, it basically states that you can use the past to predict the future. Key point here is that it's not magic. You're not going to be able to use it in a casino to win money at the roulette table, but you can use it to increase your odds of creating the most accurate forecast possible, fundamentally based on Bayes' theorem. So that being said, I've always thought that illustrating the concept of the Monty Hall effect goes a long way towards highlighting how statistics can easily be misunderstood, misinterpreted, and even misapplied in business cases. So let's make a deal. It was a really cool game show from the 1970s. The contestants on the show were randomly selected from a studio audience made up of people in Halloween-style costumes. It was a really fun show. I remember watching it as a kid and really enjoying it. But to understand this problem, what's actually happening here, it's named after the host. His name was Monty Hall. And in the show, a contestant is asked to choose between three doors, behind one of which is a prize, it's a car, and behind the other two are goats. So the game show host, he knows which door the car is behind, and he opens one of the two remaining doors to reveal a goat. Then, the important part here is the contestant is then given the option to switch their choice to the remaining unopened door. The paradox arises because the optimal strategy is to switch, even though it seems counterintuitive. Most contestants chose to remain with their original choice, and that's actually incorrect. It's not right. And so let's go over the stats on this. So let's break down the statistics of the problem so we can understand why the optimal strategy is to switch. So the original odds are here. Your choice is 1 out of 3 doors, so it's basically 1 in 3, or 33.3 repeating decimal percent chance that you have selected the door with the car behind it. So at the point where the contestant is making the choice, one of the other doors has already been revealed to have a goat. So there are only 2 unopened doors. So many people think they're making a 50-50 choice. But in reality, it's not that simple. It's actually the right choice is to make the switch, because your original, after eliminating one of the 2 remaining doors, the other unopened remaining door is still part of the original group that had 2 and 3 chance of being correct, 66% chance. So if you do make this switch, you're much more likely to win the car. And in this case, I've got a picture of a Chevy Nova, which is from the era of when this show was on. So it's a really cool car. So conclusions here. So this is sort of how Bayes' theorem works. You won't win the car every time if you switch your choice, but you will maximize your odds. And this is what the sophisticated stat modeling systems are actually doing. They're maximizing your odds of getting an accurate forecast. You can't see the future, anything can happen, but you can improve your forecast based on these assumptions. So it is essential to understand this point when designing a solution to prepare and plan for demand. Also, a note here, if this still seems counterintuitive to you, and some people it does, you can check out the Mythbusters TV show. They did hundreds of trials on this one episode. And the more trials they did, the closer they got to a 66% win rate by making the switch as opposed to keeping your original choice. So implications. How does this relate to demand planning, for example? So business users should understand what to expect from stat models and what their limitations are. Do we recommend utilizing statistics? Of course, yes, we definitely do. It's generally part of class solutions that we deploy regularly with our clients and customers. Industry leaders across the board go with stat modeling. But it's important that we coach our clients to understand some basics about stats so they can do a better job leveraging the math of this Bayesian theory. So I've seen lots of companies make mistakes or overspend resources because they're not quite understanding what the expectations should be of their models, of their stat models. A lot of times people have too much faith in an algorithm, or they commit too many resources chasing small gains in stat accuracy, not realizing that a lot of the value for demand planning anyway, and which drives almost all supply chain planning processes, is from the results of these statistical models, but added in with any of the enrichments that you make from your sales team, your business users, your experts within the business. That's the real value add. The stats are basically just a starting point, and that's why we use them, because it gives us the best chance to get the right starting point. But we really want to make sure that we coach our clients to add value by adding in various enrichments to that forecast. So it's a quick overview, and it's just a kind of a point that needs to be made. At this point, we have questions or input from our panel on some related issues that we've run across in our company related to statistics and using them as a basis for a state-of-the-art planning process. So if there's anybody from our panel that has anything to add, that would be great.
I think it's of note here that when we go into an implementation with a customer, we have to decide what level of their customer hierarchy we're going to execute those statistical algorithms against, because it may not be at the product level. It may make more sense in the business to have it at a segment or a family level, because that's where you have the reliable history. And then you're disaggregating down to the lowest level after that. You have to find the right level in your business to execute the statistics at to get the most out of the solution.
Yeah, great point, Matt. We do that all the time when we do an analysis of the history that we're using to make that prediction of the future. We use actually a statistical method to find the right level to forecast at. And that's part of our process, and that's a great point. Thank you.
Yeah, Matt makes a good point. And we actually had a client where we determined that their statistical forecast was better at a top level and disaggregated down because of the sparsity at the lower level. And we also had a separate client where they wanted to statistically forecast on a daily basis, but their historical data was so sparse that we ended up shifting it to like a weekly or monthly, and then disaggregating it back down through time, because it gave a more accurate forecast, because it reduced that sparsity in the spikes forecast.
Yeah, and our sophisticated methods of analyzing the foundational data for the forecast are what enable us to make those decisions and to give the right advice to our clients so that they are forecasting at the right level, at the right granularity, and the right time buckets, and they're interacting with that forecast at the right level or at the levels they need to. And we give them a lot of flexibility with that. But the stat forecasting is basically the first step and the foundation for everything else. So it has to be done right if you want a good supply chain planning process to be in place in your organization.
Chris, we have a question in the Q&A for the panel.
Oh, okay. So I think that's basically it. Have next week's topic. We figured we would take the next piece and go to the how do we enrich these forecasts? So if the fundamental foundational piece is a stat forecast, well, how do you get to the final operational forecast that will be used to run, to make your supply chain decisions? So that'll be our topic for next week, and hopefully we'll talk to you then. Yeah, is the statistical forecast method changed based on the number of SKUs within a company, or simply just based on available history? So it's a little of both. A lot of times it's probably more focused on based on the available history, because history that you forecast on can come in different types or classifications. Sometimes it's choppy, sometimes it's lumpy, sometimes it's continuous, sometimes there's a lot of zeros at the level that you're talking about forecasting at. So based on an analysis that we do, we'll classify your history, your items into buckets based on what kind of history they have, and then determine what is the right level to forecast at. So that is a good question, and there are quite a few different methods that we're using nowadays to do those analysis prior to actually deciding how and when and where to forecast. Anything else to add from either Matt or Michael?
While we're thinking about this, we didn't mention, but how many, I can't remember the exact, do you remember the number of math equations that exist within the statistical model?
I think there's 27 separate algorithms in the base model. And then also Anaplan offers Plan IQ, which is a more recently released set of models, which are based on the newer technology of AI and ML.
So I guess with that, how do you kind of decide on which algorithm to pick, or how they can leverage, I guess, multiple ones? How does that work?
That's a good question. Actually, what we usually do is we deploy a solution that has an automatic process, the built-in, and we do a back test on all of the statistical algorithms. And a back test gives you a readout of how accurate the model is at predicting results. So basically, you're going back in history and seeing what the model predicted, what the actuals were, and what the accuracy percentage is. And then you can automatically select from a number of different models, 27 or more models, and then let the system, recommend the best fit based on the lowest error or the highest accuracy. Several other of our clients recently have very similar style designs where we're comparing accuracy of all the different possible forecasts to see which one gives us the best starting point. So it's a real Bayesian method to get to that starting point, which is where you take it from there to enrich. And that's what we'll talk about on our call next week.
Is it kind of across the board of like CPG and manufacturing, they use a very similar algorithm to forecast, or do you see it kind of all over the place?
It depends more on the history. And that kind of goes back to James's question. It depends more on the history. So fast moving consumer goods or big industrial machines sell at different rates. So you'll have different types or classifications of history. And so based on those classifications, you'll come up with recommended ways to set up the algorithms, recommended time buckets, all those different things that you eventually decide. But the foundational process is very similar, and it all goes back to that Charles Bayes theorem.
Awesome. Anyone else have anything to add?
Yeah, I would point out that another way of thinking about the statistical modeling is that you're using math to create the shape of your demand. Through history, you can see the shape that it formats. You're using those formulas to replicate that shape.
Okay, great. Anything else?
Well, I'm excited for next week. I know we talk about enriching the forecast a lot at our clients and how impactful that can be. So again, thanks to our experts, and we'll see everyone next week. We hope you enjoyed this panel session. Be sure to check out more in our series. And if you're interested, be sure to hit subscribe and like so you can be the first to know about our next upload.